So these two are equivalent expressions, okay? So a to the power of x equals c can be written in this way: log to the base a. So the base is what you're raising, what the power is raising over here. Okay? So these things just are different ways of saying the same information. Okay? So what we'll do now is we'll just quickly go through the rules that let logs, or the sort of things you can do with logs. Okay? The laws of logs, we'll call it. So the first one is, let's do these in work. The first one is, if I have log to the base a of some letter like m, plus log to the base a of n, then I can rewrite that as one log. Okay? Do you know how they go together? If I add logs like that. So as long as I've got the same base, then log to the base a of m plus log to the base a of n can be written as log to the base a of m times n. Okay? So what logs are doing is they're turning multiplication into addition. Okay? And then we've got a sort of equivalent law, which is that if I have log to the base a of m, and I take away log to the base a of n, then I can write that as one log to the base a, and that's going to be m over it. Okay, I'll put two more over here. What about if I have log to the base a of a? So this is saying, what do I have to raise a to the power to get a? So a to the power of something is a. So what would that be? Yeah, so log to the base a of a is 1. So if we do log to the base of something of itself, then you just get an answer of 1. Because what it's saying is a to the power of what is a.
What's that thing where you put the letter in front of the log?
Yeah, we'll do that. That's going to be the last law, okay? That's probably the most important one, really. So, and another one is basically this one. What would I have to, this one's saying, what would I have to raise a to the power of to get 1? A to the power of something makes 1. So it's always 0, okay? Because anything to the power of 0 makes 1. Okay? And then the final law that's important for you guys is that if I have log to the base a of, let's say, m to the power of, let's use a different letter, k, then what we're allowed to do is take that power and put it at the front of the log. So if there's a power inside the log function, then you can take it out and it gets multiplied. Okay. Shall I just show you why this is true? I'll do a quick example, right? Okay. I'll leave it to you to try and prove all these things, but they're kind of quite easy to sort of prove. But let's just do an example of this one. We'll just sort of, I'll show you, not really a proof, but try and show you why this works, okay? Let's say I had log to the base a of, I don't know, 3 squared. Okay? Well, that's the same as log to the base a of 3 times 3. Do you agree with that? And we've already got a rule up here that says, if this rule up here that says if I've got a log of 2 things times together, I can write them as 2 logs added together. Can you see that? So this means that I could rewrite this log as log to the base a of 3 plus log to the base a of 3, which is just 2 log to the base a of 3. Can you see that? Which is just the same as bringing the 2 down to the front in that first one. So that, and obviously if it was to the power of 3, I would have 3 times 3 times 3, and I could split that up into 3, and then I'd have 3 lots of the log. Do you see what I mean? Okay. So basically, all the questions you're going to get on C2, are using those log equations to solve equations, which are usually trying to find an unknown or rearrange. And basically, the questions are asking you to just apply one of these rules, and you basically get a mark every time you apply one of these rules. Okay. So what we'll do is we'll do a few example questions, and then we'll stop. Shouldn't take long. We'll do like 3 or something like that. So I've got 2x plus 4 equals 6. Okay, and we're trying to find out what x is. So basically, whenever the unknown, the thing you're trying to find out, is in the power, in the equation, the thing you're trying to find out is up there in the power as an index, then you've got to use logarithms to solve it. Okay, on your calculator, you have got these 2 buttons here. You've got a log button. Now that's log to the base 10. So your calculator will work out log to the base 10. And you've got a ln button here, and that's log to the base e. Okay. Now for core 2, you don't need to know anything about that ln to the base e button. We're just going to use log. Okay. So you can do log to any base when you're solving these problems. Some bases will make it easier than others. But since your calculator does log to the base 10 quite easily, it's best to use that. Okay. We're trying to find out the value of x here, and the way we do it is we take logs of both sides. Okay, and we're going to do log to the base 10 of both sides. So that means basically just do log of this is equal to log of this. So what we're saying is that 2 to the power of x plus 4 equals 6. So that must mean that log of 2 to the power of x plus 4 equals log of 6. Does that make sense? Okay. Now, using the rules that we had up here, I can now solve this problem here. Okay. And the reason that we're using logs to solve it is that the thing we're trying to find out is in the power. That x we're trying to find out is up in the index there. And one of the rules of logs is that you can take that power, that x plus 4, and bring it out front.
X log 2 plus 4 and another one, or would it be, like, would you put it as one equation or 2?
This one here would become, the whole power comes down, so I would get x plus 4 multiplied by log of 2 is equal to log of 6. Okay? And then what's the next step then? Can you tell me? No, this is just something multiplied by log 2. So what would be the next step? Yeah, just divide both sides by log 2. So on this side I'd get x plus 4, and over here I get log 6 divided by log 2. Okay. Now one mistake that people make, and I'll just point it out here, is some people take that log 6 over log 2 and they change it to log of 6 over 2, which is log of 3. Now that is not true. Okay? Log of 6 over 2, log of 6 divided by log 2 does not make log 6 over 2. You have to keep it like that. Okay? That doesn't simplify. Okay? So this thing on the right is not true. You can't simplify it like that. Okay, so then the final step then is just bring the 4 over. So I've got x is equal to log 6 divided by log 2, take away 4. Okay, and that's the answer. Now on the exam it might ask you to leave it in terms of logs. Okay, but if you want to get an actual value, then you just grab your calculator and you do log 6 divided by log of 2. It's 2.58, and then you take away 4, and you can write down the answer. Okay. So what was it? Minus. Let's have a look again. Minus 1.4. Okay. The reason it might ask you to leave it in terms of logs is it's just more accurate. Okay. You got it? So this is going to be question 9 from, what is it, Jan 07. C2 exam Jan 07. Okay, and it says, so, first of all, the first question for part A says solve the equation 3 log A 3 log to the base ax equals log to the base a of 8. Okay, so what do you think we do with that? It's worth 2 marks.
Yeah. Log AX cubed.
Yeah, so I can bring that 3 inside. So what I've got is log to the base a of x cubed equals log to the base a of 8.
Let's just set that on.
Then I can get rid of the logs, yeah, because we're saying log to the base a of this is equal to log to the base a of that. So that must mean that x cubed equals 8. So x must be the cubed root of 8, which is 2. Okay, so that's the first question done. Okay, so notice that question just involved you knowing one of the log laws. Okay, so part B. Part B says that show that 3 log to the base a of 6 minus log to the base a of 8 equals log to the base a 27. Okay, so yeah, basically you want to just keep applying log rules one at a time, and you pretty much just pick up marks. So this first one, Sean's saying change that to that. Are you happy with that, Isaac? Yeah. Okay. That's like 8. Oh, I think there's a quicker way of doing this, you know, Sean. Matty, sorry.
6 cubed minus 8 isn't 27.
Yeah, but 6 cubed divided log 8. 6 cubed divided by log 8 equals log 8.
I think there's a better way of doing this one. Do you want to carry on through it or not? Oh, this is okay, really. So what's the next step? Yeah, what's the next thing to do?
Divide log 6 cubed.
You can turn this log 6 cubed minus log 8 into one log, because it's minus, then you can divide them. So I get log the base a 6 cubed divided by 8 should be equal to log 27. Okay, what's 6 cubed divided by 8? Can we do that? Oh. Yeah, it should be, yeah.
216 divided by 8.
Yeah.
So
Yeah. So that's proved it, yeah? So the two things are equivalent. I think there's a slightly quicker way of doing it, which I'll just go through now. If you leave that 3 log a like that, and then write this one, because it's log of 8, you can write this as 3 log a 2. Do you agree with that? Because 2 cubed is 8. Yeah? And what about the last one? Can we write that with a 3 in front?
3.
Yeah. Okay. And then I can get rid of all the 3's because I can divide everything by 3. And what I get is log a 6, take away log to the base a of 2 equals log to the base a of 3. So this gets me log to the base a of 6 over 2 equals log to the base a of 3. And that's true as well, isn't it? Okay. So either way is fine. Okay. Should we finish off this question then? Okay. For part C, it says there's a point 3p that lies on a curve, and the curve is y equals 3 log. 3. Girls, quiet down, please. 3 log x minus log 8. Okay, so it says the point 3p lies on the curve. So if it lies on the curve, 3 is the x value and p is the y value, right? So what we'll do is we'll put 3 in as the x value. So we'll say, let's put 3 in as the x value. So this must be 3 log 3 minus log 8, which gives me log 3 to the power of 3 minus log 8, which gives me log 27 minus log 8, which gives me log of 27 over 8 by putting those logs together. Can you see that? So that's what p equals. So we prove that bit. Is that okay? Okay, and then part C part 2, just do that. It says there's another point Q, and this has got the coordinate 6Q, that also lies on the curve, the same curve. So the curve is y equals 3 log x minus log 8. Okay, show that the gradient of the curve is log 2. Okay, so first of all we're going to find out what Q is. We'll do it exactly the same way. So I'll put Q in there. Sorry, to find out what Q is, I'm going to put 6 in there. So I'm going to get 3 log 6 minus log 8. And I'll get log 6 to the power of 3 equal minus log 8.
What we just done.
Yeah, it is just what we've just done. So log to the 6 to the power of 3. Isn't this just log 27? Can you see that from the top, from part B? If you look at part B, we've already worked out that there is the same as log of 27, haven't we? So Q is log 27. Do you agree with that? No, we just found the Q value, the coordinate. Yeah. Okay. So what we've that's the same as part B, right? Okay. So what we've got then is we've got 2 points. We've got a point P on the curve, which has the coordinate 3 and log 27 over 8. And we've got point Q on the curve, which has the coordinate 6 and log 27. Okay? And we're trying to find the gradient of the line PQ. So how do you find the gradient of the line PQ? Yeah, it's the difference in the y divided by the difference in the x's, isn't it? So the gradient, let's put it as m, the gradient of the line PQ is the change in y, so y2 minus y1 divided by x2 minus x1. So let's put that in. We've got the change in y is going to be log 27. Log 27. Take away log 27 over 8 divided by the difference in the x's, which is going to be 6. Take away 3. Is that right? Okay. So let's see if we can simplify this. Can I put? What do I do with these? Log 27 take away log 27 over 8. Take away logs. What's that the same as? Dividing. So this goes into 1 log, and the log is 27 divided by 27 over 8. Now we talked about this the other day. Yeah, we'll come to that in a sec. And on the bottom it's just going to be 3 though, isn't it? Do you agree with the bottom? Okay. Now let's see if we can deal with this log 27 divided by 27 over 8. What's that the same as? When I divide by a fraction, how does it work? Flip it and times it. So is that just log 8? Do you agree with that? Just check. Yeah, so the 8 comes up and the 27's cancel. So it's log 8 over 3. But I could also write that as a third log 8, and which means I can also write that as log 8 to the power of a third. And what's the power of a third mean? The cube root. So this is the cube root of 8, which we already know is 2, and that's what we were trying to show. Okay.